talk about the hyperbola. Boys, come on. Yeah. So this is new for most of you, so let's pay attention. A lot of it is similar to what we've already done. We are in our notes, and we are on page 56. I think we may have one more problem to do. Yeah, we have one more problem to do. So we're on the back of page 55. This is still an ellipse. So on the back of page 55, the very last problem, let's do it first and then we'll do our hyperbola work. So it says the center is at 4, 1. And vertices are at negative 1, 1. And 9, 1. And 4, 4. And 4, negative 2. All right, so here's the job. We are in the last problem on the back of page 55. We are writing the equation of that ellipse. So on the last problem on the back of page 55, or 55, I'm sorry, 55. The last problem on the back of 55, it says write the equation of this ellipse. Now we know that an ellipse looks like this. It has an x parentheses over something plus a y parentheses over something equal to 1. That's what your ellipse equation looks like. Okay? If you're confused by that, look at the very top of the page, and there's an ellipse. That's what they look like. Now we know our center goes in here. So with that center, this will be x minus 4, y minus 1. That gives me a center of 4, 1, right? Now think about the quiz you just took. There was a number down here. And you square rooted it and counted that far sideways, right? So let's work that backwards. How far am I counting sideways? 5. So this number has to be a 25 because that's why I would count 5. How far up and down did I count? 3. So this number has to be a 9, and there you go. That's it, you're done. So that was the last ellipse problem. So now we're on page 56, and we've got this equation. Now take a good look at that equation and tell me if you notice anything different about it. It's a subtraction. When you have a subtraction, that tells you that you have what's called a hyperbola. Now in a minute I'm going to graph it for you, so if you're not sure what a hyperbola looks like, you're going to know in a second. But first of all, we have all kinds of stuff we have to find. So the first thing is the center. Now take a look at that equation. Where do you think the center is? The origin, 0, 0. How do we know? What about the equation tells you you're at the origin? Abby says there's nothing added or subtracted to it, right? It doesn't look like this, right? It's got nothing added or subtracted to it. That tells me it's at the origin, 0, 0. That is the center. That is where we're going to count, okay? From. We're starting at the origin. This 9 means exactly the same thing it meant with the ellipse. So what does that 9 tell me to do? Go right and left 3. So 1, 2, 3, 1, 2, 3. So that would be negative 3, 0, and that would be 3, 0, right? Now, what does that 16 tell me? Up and down 4. 1, 2, 3, 4. 1, 2, 3, 4. So far, I'm doing everything exactly like I did with the ellipse. Everybody okay with that? Okay, now here's the first difference. Before, when this was an ellipse, you made an oval through those points, right? Now we're going to draw a rectangle through those points. So you'll see why in a minute, but I want you to draw a rectangle through those points. So instead of connecting them, Jalen, instead of connecting them with an oval, you're going to connect them with a box. Got it? Now, once you get the box drawn, I want you to draw in the diagonals of the box. You know what I mean by diagonals?
I remember this from last year.
Well, yes, that's magnificent.
I wasn't good at it, but not good.
So we're going to draw in the diagonals of the box. Those diagonals are called asymptotes.
Asymptotes? Stop.
Those are called asymptotes. Remember, we don't say the P in that word. They're called asymptotes. All right? Now, in a minute, we're going to find those equations, but not right now. First, I need to draw my hyperbola. Now, I need you to pay real close attention. The letter that comes first in the equation is the key. So x comes first in the equation. So that means my hyperbola opens in the x direction. So start at the corner of the box and let the asymptotes be your guiding lines. So I'll do it in red maybe so it sticks out a little more. This is going to be my curve. This is what my curve looks like. It follows those asymptotes. So it starts right here at the edge of the box, and it looks like that. That red thing is my hyperbola. These points right here, this one and this one, are called the vertices. Those are the vertices. So when your problem says, what are the vertices, you're going to say they're negative 3, 0, and 3, 0.
We don't do them on the top and bottom?
No, because the ones on the top and the bottom, well, are they part of the red curve? No. Now, they're important because they help me build the box. But the vertices are part of the curve. And the only points that are part of the curve are those.
So you can't just draw one
Huh?
on the top? You can't just draw one on the top?
No. I mean, I don't care what you draw, I'm not grading your picture. But there are two vertices. These are the vertices. So if you put down anything else as vertex, it's going to be wrong. Okay? Now, this axis that joins the vertices, everybody see what I'm drawing right there? That axis right there is called the transverse axis. And you will remember that because in the word is the ver for vertices. So the axis that joins your vertices is called the transverse axis. So when, like on your next quiz, there'll be TA. That's transverse axis. How long is it? Well, in this problem, it is 6. So that's all you need to put down. In an ellipse, we call it major and minor. In a hyperbola, there's different vocabulary. The one that joins the vertices is called transverse. The other one, this one right here, this axis, is called the conjugate axis. And the conjugate axis in this problem is 8. Because you counted up and down 4 when you built the box.
So that's all you put those?
No, so far, we're not done. All right, now take a look at that curve. if you had to guess where the foci are,
So the transverse is wherever the verse is.
the foci are here. Now, at the beginning earlier, Jalen said, is a hyperbola like two parabolas? And it kind of is, if you look at this, right? So if you think of this as a parabola, wouldn't that be where the focus is? And then on this side, you've got one over here. So now we got to figure out what those points are. In an ellipse, we find the distance from the center to the focus by subtracting the denominators and taking the square root. In a hyperbola, you add the denominators. So this is going to be the square root of 9 plus 16, which means 5. So we're going to start at the center. This is our center. And we're going to go straight forward 5. So since that's the origin, we'll be at 5, 0 and negative 5, 0. Those are your foci. So start at the center, and whichever way you're going, in this case it's sideways, we're going forward 5 and backward 5. How did we get 5? We added the denominators and took the square root. Okay? So, when this sign's a minus, you add the denominators. When it's a plus, you subtract the denominators. The equations look exactly alike, except for that sign. So if it's an ellipse, if that's a plus, you subtract these. If it's a hyperbola, it's a minus, you add these and take the square root. Okay? Now, there's one more thing we have to find. We have to find the equations of the asymptotes. So we are going to find the equations of these blue lines. Okay? Now, equations of lines, I'm thinking y equals mx plus b. Right? I need a slope and I need a point. I need a slope and I need a point. The point, you're always going to use the center. The asymptotes always go through the center. So for all your hyperbolas, you're going to use the center, whatever that is. So in our case, that's going to be 0, 0. To find the slope, first of all, there's two of them, two asymptotes. When you find the slope, think about how you build the box. You started at the center, and you counted up how many? 4, and over how many? 3. So the slope is 4/3 or negative 4/3. Well, now I gotta write the lines, but those are the numbers I'm using. The slope is always going to be however many you counted up, however many you counted over when you built the box. One of them will be positive because you're going that way. One of them will be negative because you're going that way. But they'll be the same number. So now, y equals mx plus b. This is good review. I'm using this point, and I'll do positive 4/3 first. So 0 equals 4/3 times 0 plus b. B turns out to be 0, so that equation is 4/3 x plus 0.
All one problem.
This is all one problem. These are huge.
So for our asymptote, you want us to write that.
This is the equation of the first one. Now I gotta find the second one. So y equals negative 4/3 x plus b. You have to write an equation using the positive slope and the negative slope.
Could you just put plus or minus?
Not unless the center's at the origin, and we won't have any more at the origin, so no. You gotta do it separately. So there are your asymptotes. Mrs. Ford, is that one problem? Yes, it is. That is one problem. But we've done everything now. We found everything we were asked for. So let's make sure you understand all this stuff. We got a center, vertices, foci are the green points, asymptotes, and then our transverse and conjugate axes.
What would
What's the
What?
So like when you're like, you know, like you like translate these to like real life, what would a foci?
Well, the definition of a hyperbola, the definition of hyperbola is the set of points in a plane, the difference of whose distances from two fixed points is constant.
Wait, so is the transverse and the conjugate the answer, or is that just a problem?
You'll need to tell me the length of the conjugate axis and the length of the transverse axis. Those will be two questions that go with this.
And is it always, is transverse always X or Y?
No.
What is that?
No. Look at the next problem.
Do we?
Never. Never. Look at the next problem, guys. We're not going to get this done, but I want to at least get it started.
Well, the center is a 3.
No, I'm looking at B.
0, 0.
So the center for B is still at 0, 0. Guys, it is so rude and disrespectful. Stop it. The center's at 0, 0. Now this is another one, kids, just like some of our parabolas, where you really have to be paying attention. In this case, since they're both 0, it doesn't matter. But if this had been y minus 2 squared and this had been x plus 3 squared, you know what I'm going to caution you about? Where's the center? Negative 3, positive 2. So make sure that you are paying attention to the order of the points. So the center is at the origin. This says go up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And sideways 1, 2. 1, 2. Now, does that bother anybody? Is everybody clear on that work? Counting up and down 5, sideways 2. Now let's make our box. And here will be the asymptotes. Just drawing the diagonals, and those are the asymptotes. Now here comes the critical thing. You gotta get it opening the right way. Pay attention to which letter comes first. That's the key. In a hyperbola, it's the letter that comes first. So, since y comes first, it's gonna open this way. Now, that means that this is my conjugate axis, or excuse me, my transverse axis. Would you agree with me? That's my transverse. So my transverse axis is 10. Remember, transverse vertices. My conjugate axis is 4. Since I'm opening this way, would you agree that my foci are here? Right? So center to focus. What do I do to find that distance? Add them. So it's going to be 25 plus 4. The square root of 29. Now I'm not going to panic. I'm going to start at the center, which is at 0. and I'm gonna go up root 29. So 0 plus root 29, this point's gonna be 0 root 29, isn't it? If I went up 6, wouldn't it be 0, 6?
Could we write 5 plus root 29?
No, you start at the center. It's 0 plus root 29. This is center to focus, not vertex to focus. Center. Everything starts at the center. And then this one is negative root 29 because I'm going down root 29. Okay? All right, I'm going to stop there for a minute because I got one thing I need to run by you that just came up during lunch. And I'm not sure